Good afternoon. Is this on? So we're here to talk about nuclear. As we just said, it is a very dynamic time for the nuclear industry, from regulatory modernization to restarting once shuttered plants to congressional action and administrative focus and executive actions. Huge developments in the advanced nuclear technology space and policy space. There's a lot to talk about. So I'm Melody Rodriguez, as she said, and I'm here with a really, really amazing panel today. I have Jeremy Harrell, Rita Baranwal, Patrick O'Brien, and David Brown. And I think maybe the best way to start this off is to maybe ask each of you, and I'll start with you, Jeremy, to tell me a little bit about yourself and your organization and the role that it plays in the nuclear sector.
Yeah, absolutely. Thank you, Melody, and thank you to the entire team putting on this conference. I think it's been a really great conversation over the past couple days. My name is Jeremy Harrell. I'm the Chief Executive Officer for ClearPath and ClearPath Action. I've been at ClearPath for a little over 8 years. Before that, I worked on Capitol Hill, working for Republicans on the House and Senate side, focused on energy, transportation, and national security policy. For those of you who may not be familiar, so ClearPath is a DC-based conservative clean energy organization, and our mission is to accelerate technological innovations needed to meet the globe's energy and environmental needs. So what does that mean? Policies that can commercialize and drive the deployment of new technologies like advanced reactors, like enhanced geothermal systems, energy storage, and how do we make building blocks of the global economy like cement, steel, fertilizer in an affordable and lower carbon way.
Well, thank you for having me. I'm Rita Baranwal. I'm the Chief Nuclear Officer for Radiant. Radiant is a company that has a mission to mass produce portable microreactors. So our product, it's called Kaleidos. It's a 1 megawatt electric microreactor. Really excited to share with you that we have had a huge series of firsts over the past few months. We were the first to go into what's called DOME, the demonstration of microreactor experiments at Idaho National Lab in the refurbished EBR-2 dome. We were selected by DOE as well to receive an allocation of HALEU, and we were the first to sign that HALEU contract. We were the first to receive an award from our military here in the United States for providing microreactors to the Air Force. And we heard Representative Wahlberg talk about the big UK-US announcements, and I had the extreme privilege of speaking to the Prime Minister on Monday and sharing with him the news that we signed the first commercial HALEU contract with Urenco on Monday. So there's a lot of excitement going on in the nuclear sector, as we've already heard and already are aware of, but I think the folks here are actually deploying, and they're walking the walk. So I'm really excited to chat about this further.
So I'm Pat O'Brien. I'm the Director of Government Affairs and Communications for Holtec International. Have spent my last 10 years of my career in nuclear, 4 years in operational experience at the Pilgrim Nuclear Power Plant, and then I kind of joke that Holtec bought me with the furniture to decommission the plant, and I've kind of come along for the ride. And Holtec is a very innovative company. What we're originally known for really is spent nuclear fuel storage, both wet and dry. We did get into the decommissioning space about 8 years ago, and then a funny thing happened along the way with us decommissioning the Palisades plant, and I think you heard Chairman Wahlberg talk about it. We are planning to restart that plant by the end of the year. That'll be a first in the industry, and we've been happy to lead that. In addition, we're working on our own small modular reactor design, 340 megawatts, dual unit plants that we're going to deploy the first two at the Palisades plant by 2030, 2031.
Great, and I'm David Brown with Constellation Energy here in DC. Constellation, as you probably know, is the largest owner and operator of commercial nuclear power plants in the U.S. We have 11 reactors in Illinois, 4 in upstate New York, another 4, soon to be 5, in Pennsylvania, and 2 in Maryland, just about an hour from here. We also are part owners of 2 units in New Jersey and another 2 in Texas. So very busy these days.
So like I told you, I have a very impressive panel here with me today. I think that maybe to start off the discussion, Jeremy, I might turn to you. So from your vantage point at ClearPath, and you do a lot of policy work, and thought leadership in the nuclear space. Maybe you could give us an overview of where you see the nuclear industry today, kind of where we are and where you see us going.
I've never been more excited about the future for nuclear power, and there's really four major reasons for that. One, you heard a little bit about it from the other three panelists here, the immense private sector momentum that is happening between innovators, operators, that give me confidence that the light at the end of the tunnel for new builds in nuclear is pretty bright and pretty close. Two, we are seeing an immense amount of new investors into the sector. We've seen some of the largest financial institutions in the globe say that they want to be behind the major global push to 3x nuclear. We're seeing new investors from the tech industry, from heavy industry, and folks like Nucor and Dow and New Designs, because they know they need advanced reactors to meet either heat or affordable power needs. We're seeing immense new demand, right? Over 31 countries who have committed to 3xing nuclear. President Trump's goal to quadruple nuclear here in the United States by 2050, so upwards of 300 gigawatts to meet our rising demand needs. And we've seen, finally, immense bipartisan policy support over the last decade, and I'm really proud of the work that many of us in the ecosystem have done, the incredible work that our policymakers, many that you all have heard from here today at the conference, to put new investments behind the industry, invest in supply chain, invest in our fuel capacity, and ultimately find a way to drive forward the next generation of nuclear reactors.
So I would like to now maybe focus on like domestic, and I want to turn to you first, David. So Constellation operates the largest nuclear fleet here in the U.S. And I would like to hear from you a little bit about how plant life extensions, restarts, safety enhancements, how all of those things are helping us meet our increased energy demand here in the U.S.
Sure, thanks. And, as Jeremy said, boy, what a sea change. 5 years ago, we were actually closing plants. Today, we're looking at new build and all the rest that goes with it. And I think that's a result of kind of broad public support, broad political support, which results in broad policy support, and then price support at the end of it with all this new demand coming over the horizon. So one of the things that we continue to hear from our customers, including hyperscalers and others, is, boy, we need power fast. What can we do to get megawatts on the grid as soon as possible? And so while Rita and her compatriots are out looking over the horizon on new build, we are trying to squeeze as much juice as we can out of the existing fleet. And we're doing that in three ways. First, we are restarting 3 Mile Island, which is a plant that we closed in 2019 for economic reasons. Unit 1 of that reactor, when it closed, was one of the best performing reactors in the world, but just could not compete economically. About a year ago, we announced that we have entered into a 20-year power purchase agreement with Microsoft to restart the plant and sell them the entire 835 megawatt output from that unit to power their needs in the PJM region. We'll do that, put that plant back online in 2027 at a cost of about $1.6 billion, so just a fraction of what a brand new plant that size would normally cost. The second thing that we're doing is uprating our plants. In the nuclear industry, for whatever reason, they call it an uprate. You might otherwise call it an upgrade. But we are switching out plant components like turbines and other equipment to make the plant more efficient and get more megawatts out of the same unit. That can go anywhere from literally 2 or 3 megawatts of additional power to upwards of 300, 350 megawatts of power. So to date, we've announced probably about 400, 500 megawatts of additional projects that we can get online, we think, in the next 3-4 years. We think there are probably another 1,000 megawatts that our fleet is capable of producing if we find a customer for that power. And I think the Electric Power Research Institute has estimated that there's anywhere from 5,000 to 8,000 megawatts of uprates possible looking across the industry. And then the final thing that we're doing is working to relicense the units that we've got. When you build a nuclear plant, you get a 40-year license. The law allows you to extend those licenses for 20 years at a time. So most of the plants in the country are licensed to run for 60 years. We're in the process of extending those to run for 80 years. And there's no reason that they can't continue to be operated safely and efficiently. Reactors in the U.S. today run about 92, 93% of the time. So they are that baseload, clean, firm power that the nation needs and our customers are looking for.
Thank you, David. And I think, we are all so excited about the advancements in nuclear, but it starts with keeping the existing fleet really strong and optimizing performance. Also, really quickly, before I move on to the next question, I want to let you know that we are open to take questions from you guys. And I think you can submit them through the app. And if not, we'll kind of do a call for questions at the end. I just want to put that in your ear. Patrick, we were just talking about, you mentioned the restart, and David had his opportunity to talk a little bit about TMI. Do you want to talk a little bit about what's going on at Palisades and give us an update there?
Yeah, absolutely. The last 3 years have been a lot more fun in my career than the first 7, where I spent a lot of time shutting down reactors, unfortunately. The bipartisan support that Jeremy spoke of is really key to what we're doing at Palisades. Shortly before we took that plant over for decommissioning back in 2022, Michigan governor kind of stepped in and said, is there any way you can keep this plant in a condition to potentially restart it? As a privately held company with maybe a little bit different risk register than most, we thought it would be kind of fun to look into that and see if it was possible. So I'm happy to say we've gone through that over the last few years with a lot of support from the federal government, the state of Michigan, and then really locally. Acquiring a $1.5 billion loan from the DOE loan program, $300 million grant from the state of Michigan, and then putting about $500 million of our own capital and equity into that. We are on track, like I said, to restart it at the end of this year. It's been significant in the sense that we are on time and under budget. I want to say that again, on time and under budget. You don't hear that in nuclear ever. We just got I think it was the 6th loan disbursement. We've taken in about $500 million of that $1.5 billion authorization. So we're doing well with it. A lot of major component replacement, and I think the nice thing, having worked in an operating plant, usually your refueling outages 30, 40 days. You do a significant amount of work in that time. For us, it's really been a 1.5 year outage where we've been able to take large pieces of key equipment off-site to refurbish, replace, and really significantly invest in the plant so that when it does come back online, it will be like a new plant again. So we will go almost immediately into relicensing because the plant's license is up in the early 2030s. And then at the end of the year, fingers crossed, everything's back on the grid. We'll go immediately into licensing those 2 SMRs I talked about as well. So it's really a nice, I think, story about kind of bringing back both the industry. We're happy to see with the Chris Crane Energy Center coming back with TMI, and then potentially with Duane Arnold as well. It's kind of a nice story. You see the value in nuclear again that I hadn't seen for a long time in the industry, and hopefully, internationally they may follow suit as well.
Yeah, so Patrick, I want to pull the string on the SMRs a little bit.
Sure.
And move and pivot into kind of the next generation of nuclear. Sure. And maybe you could talk a little bit about, some of the benefits of this technology and when you think we might start to see some of these online.
Yeah, I think, there's a lot, SMR, very generic term, I think, for small modular reactor. There's a lot of different kind of designs. Our design at Holtec's a very simple pressurized water reactor design, so we feel like it's known technology with off-the-shelf components that we can kind of bring to market and commercialize pretty quickly. We are a company that at our core manufactures big pieces of metal every day. It's what we do. It's what we've done for 40 years. So we have a plant in Camden, New Jersey that was built in 2017 with the desire to build small modular reactors out of that facility. We plan to order the reactor vessel and steam generators to be built in our own factory by the end of the year. So we're actually starting this, putting our money where our mouth is, and moving this process along. With our licensing efforts to start at the end of the year, we really anticipate 2030, 2031, where we will construct in parallel to licensing through the Part 50 license, the 2-part license. We anticipate that first unit would be completed 2030, most likely online in 2031, with Unit 2 to follow. And then from there, honestly, we have plans to continue to deploy. I think one of the things people maybe started to realize recently is we got into the decommissioning business because we saw it as an opportunity. not just to show that we can complete the life cycle of nuclear, but also have property that is, has a nuclear history, has support in the communities for nuclear, understands the risks and benefits to deploy new nuclear on. So we would intend to follow quite quickly after Palisades with the Oyster Creek facility in New Jersey in 4 units.
That's excellent news. We like to hear it. So from SMRs to microreactors, Rita, I would love to talk to you a little bit about, Radiant has this cutting-edge advanced nuclear technology, fuels. Maybe from your vantage point, I would love to hear the status of advanced reactor deployments and kind of the challenges and opportunities that you see moving forward.
Sure. So kind of piling on to what we've already heard, the beauty of being at this moment in time is not only the advancements that we've had in the technologies, as you've mentioned, but sitting here in this city, in this administration, with the acceleration of reforms in regulatory space, it has been so serendipitous to what we're all trying to do. And Radiant is absolutely taking advantage of being in this moment in time. And so what we're doing is providing inputs, and we have, to the Department of Energy on where we think that they can reform some of the regulations. We have provided our inputs to the NRC, where we think they can accelerate and reform some of the regulations. And we're starting to, I would say, anticipate that, and we're not alone, by the way, this is not just Radiant, the industry collectively is doing this, but we're starting to anticipate that some of those suggestions are being considered, and we are going to see reforms in both DOE and NRC regulations. So that's a good thing. It's in the direction of goodness because our reactor is much smaller. There are different regulations we think that should apply to the smaller reactors versus the TMIs and in between even to the SMRs. The technology itself is not new. It's decades old. We're using good old helium gas to cool the reactor, the same helium you use in birthday party balloons. And high temperature, it's a high temperature gas reactor concept, and we're using TRISO fuel. So how many of you have never heard of TRISO? Please raise your hand. All right, good, because I'm going to talk to you guys. TRISO is an extremely robust fuel. It is melt-proof. And it's basically really small BBs. Imagine a poppy seed that has been coated 3 or 4 times with silicon carbide or carbon. That poppy seed is uranium. So the blow up that I take, I have a prototype that I take around on show and tells. It looks like a gobstopper. So how many of you have had a gobstopper or broken your teeth on one, right? Yeah. So that's what it is. But that center of the gobstopper is uranium. Everything else around it is meant to protect fission gas from releasing out into the environment. So we take those small BBs, we encapsulate them into graphite pellets. We load those graphite pellets into an additional graphite, essentially it's a module. That goes into the reactor. The reactor is shielded, and there's several other layers of shielding in between that. I mean, talk about defense in depth. So the reason we do this is because of the application. I talked about the military applications. I talked about the portability. You need that to not only demonstrate to the regulator that we do have all of our safety analyses in place and we're using materials and designs that are inherently safe, but then also when we do want it to be portable, you have to ensure that safety to everybody that this touches along the way. Our nuclear fuel is transported across the roads in this country every day. Most of us don't know it because, frankly, we don't have a need to know. But it has been done for decades and been done without incident. So we're doing things using technology that has been developed a long time ago, putting it into forms that might be unique, using it for applications, and deploying it more quickly, though. So that's really what's new. Our technology, once it's delivered to your site, can be installed and ready for operation in 48 hours. 2 days. There is no excavation needed. There is no construction on site needed. I get calls from my friends in the construction services side of things all the time. And I'm like, well, yeah, that's great. Let's keep in touch, but I don't need you today, and I don't need you for this technology. So that's a good thing. The barriers, and this is going to be funny, but there is congestion in the supply chain. And it's a good problem to have. But for example, Radiant was one of the companies among 10 or more to be selected by the DOE in the reactor pilot program. all of us need fuel. There is going to be a line at the few fuel vendors that exist in this world, frankly. But for certain purposes, you need to have U.S.-produced fuel. So there's literally less than what we can count on my hand in this country that can do that. So that's going to be the barrier. And I like to think, and Radiant's walking the walk, the early bird gets the worm.
And maybe I'll open up to the rest of the panel. Are there some challenges or opportunities that any of you see kind of moving forward with nuclear that you would want to? I see Patrick.
Yeah, no, I think one of the key things for all of us is going to be workforce. I mean, when I was at a plant that then was ultimately shutting down, at that time, 55% of that plant was retirement eligible. So there's a lot of knowledge base that we're losing in this industry. And with the Palisades restart, I was happy to say, we went from 200 employees in decommissioning back up to 600. About 100, 125 of those came back, and some of them, quite frankly, said, I'll give you 2 or 3 years. I want to share all my knowledge. But really, the ability to find a workforce that's going to be able to construct everything we're looking to do is something we really have to focus on before. And I was happy to hear Chairman Wahlberg's comments on, workforce development, because that's something when I'm doing state level lobbying, we're hearing a lot of, how do we help you build that workforce and get ready for what's coming next?
Yeah, and I think the other missing thing in that conversation is just the components. I mean, the nuclear supply chain has really atrophied over the last 20, 30 years here in the U.S., so we're kind of reliant on Germany and other nations to kind of provide those large forgings that we need. So we need to reshore some of that, make sure that the stuff that we get is coming from allies, and that's kind of a very long-term effort. But I think workforce is really at the top of the list as well, as is fuel. Not only the advanced fuels for the advanced technologies, but light water fuel. Right now, for many complicated reasons, we are overly reliant on Russia, China to a much lesser extent, but then the Europeans as well. There's very little domestic enrichment capacity here in the U.S. There's one facility in New Mexico that can meet about 1/3 of the U.S. needs. So that's not the best place to be when you're looking to expand your footprint.
So we just talked about a bunch of challenges. So Rita, I would actually like to ask you another question. Based on kind of being the former head of the Office of Nuclear Energy, can you talk a little bit about your thoughts on how DOE and the national labs could work together to help accelerate next generation deployment?
Sure, and it's happening now, so I'm not, offering a suggestion or prescribing something. It's happening now. That industry can certainly leverage the expertise that resides in the national laboratories. They can lean on the facilities that are there. They can access the historical data that has been generated with our taxpayer dollars over the decades. And the reason why I know about that is in a prior life, I was the inaugural director for GAIN, which is the Gateway for Accelerated Innovation in Nuclear, and that was one of the major premises of GAIN is to match up private industry with the national lab capabilities. I will not be sharing something novel when I say we can always use some more DOE funding. But again, it needs to be with discrete milestones in mind and discrete deadlines. And so this administration, again, is really forcing us to look at how quickly we can do things, but do it in a way that we achieve the certain milestones that we set out to achieve, and we do it in a very judicious manner if we are using government funding. That said, Radiant is actually over 95% privately funded, but we very much appreciate the DOE's faith in us by allowing us to be first in dome and the other accolades that I've already mentioned that we've been selected for. But again, continuing to access the expertise that is within DOE and the government agencies as well as the National Lab is what I would encourage all of us to continue doing, because there is absolutely no sense in reinventing something that's already been done.
I would just add, like, I agree with Rita. I think there's a huge opportunity here to put the whole of government behind deploying this next generation of new nuclear. I think we've seen encouraging signs from the administration's executive orders in ways of how can we get creative with DOE resources and do project delivery faster. How can we deploy on federal sites, whether it's DOE sites or at military facilities where we can increase base resilience by deploying micro reactors? That's incredibly important. Can we leverage tools like the Department of Energy's Loan Program Office to help us build the order book for new reactors, for example? We are really at an all-hands-on-deck moment. Like, power demand is the long pole in the tent in a wide variety of things where we're competing globally, and nuclear can play a really important role in meeting that. But we've got to do things a little differently than we have done on the past on the regulatory and in the way that we partner with the government. And I'm encouraged that I think a lot of the leaders in the industry, like the folks here on the stage, and some of our officials, career and political, and at the federal agencies are thinking outside of the box and looking to find new ways to accelerate deployments.
Before I move on, any other thoughts on kind of what
No,
Congress?
I think you both hit it on the head. I think for us, it's really time for the industry to put our money where our mouth is. They've done, the government's come up with a lot of money for R&D. Now we have to commercialize that, and that's key. I mean, if we're going to ask for more money, loan program office, whatever it may be, we actually have to show we can build it here, replicate it here, and not repeat the mistakes of the past by customizing everything and not having standard designs that you can just go from place to place deploying.
Okay, then I want to touch on a subject that we actually have not touched on yet, and then I'll open up to some questions from the audience. I think I just saw a hand go up, so let me just do one more question, then I'll move on to you. I want to talk a little bit about AI demand, and David, I'm going to turn to you and then open up to the panel, specifically turning to you because of the TMI restarting as the Crane Clean Energy Center. That was, Constellation signed the largest PPA with Microsoft to do that. And so I want to know kind of, how's that project going, first and foremost? But secondly, are there any insights that you might be able to provide into kind of how you see power producers getting ready for that AI demand that we all know is coming at us?
Sure. Good news is the Crane Clean Energy Center, which was originally scheduled to be online in 2028, now going to be 2027. So we're about a year ahead of schedule, which is fantastic, due in large part to PJM kind of reshuffling their interconnection queue and helping us out there to prioritize firm power sources. And so far, again, a great story on the budget side as well. It's funny, after we made that announcement, there was an article in the Washington Post where the reporter said, well, every expert that I've talked to said there's no way they're going to do this on time or on budget. And our CEO, being who he is, had a call with the team later that afternoon and said, what do we need to do to accelerate the schedule by 6 months and cut the budget? And so we're well ahead of that schedule, which is fantastic. And so far, right at or below budget. And, staffing, I think of the 650, 700 folks that we eventually are going to have working full-time, we've already got about 400 of them lined up, including the first 2 classes of operators. So we're making great progress there. The other big announcement that we made earlier this year was with Meta. They are going to buy the entire output of our Clinton Power Station in Illinois. That's over 1,000 megawatts generation. We're also going to uprate that plant by 30 megawatts, and they'll take all that as well. And they're interested in exploring the potential for new nuclear, too. So, again, I think given their interest in speed to market, we're focused on uprates right out of the box. The restart, again, very limited, though, with maybe 3 units in that universe. And then we'll kind of look over the horizon on the new plant development.
I mentioned in my early remarks, one of the reasons why I'm so excited about nuclear is the influx of new investors, and David touched on this a little bit, but you're seeing the hyperscalers put money where their mouth is, right? Amazon has invested in at least one company. Google has invested. Meta has made investments. Microsoft has made investments in not only increasing capacity at existing facilities, but in new reactors. And it's because nuclear can play a really important role in meeting that significant demand that's coming from data centers, from AI, but also from increased focus on manufacturing in this country as a whole. And so, U.S., we're in a race with China on this. 70% of data center capacity last year came from the U.S. and China. We're going to need more of all power. Nuclear can play a really important role in it. And I was really encouraged to hear Congresswoman Lee and Wahlberg earlier talk about the need for technology agnostic permitting reform, because we're going to need a little bit of everything. We're going to need wind, solar, nuclear, gas, and geothermal, and the required infrastructure needed to enable this.
Yeah, and I think one of the things too, AI on top of that is advanced manufacturing. We want to onshore manufacturing. There's a huge demand for energy needs for those as well. So it's not just the data centers. If you look what's happening in New York, Indian Point, which we're decommissioning, was shut down 5 years ago. They are now looking to add a new gig of power in the north, and a lot of that has to do with the fact that they were very successful with the CHIPS Act, bringing Micron in to build the $1 billion manufacturing plant there. But that one plant alone is going to take as much power as the state of New Hampshire and state of Vermont combined. So where do you get that from? I think there's some concerns that potentially some of the assets that are already in the state might be, kind of, I'll say, co-opt for power needs for that, and then that would affect the grid. So, really trying to look ahead to both onshore manufacturing but meet the AI needs as well.
And despite the needs being very, very large, there are tech companies that want smaller options as well. So we have a partnership with Equinix, and they have agreed to 20 of our microreactors. So certainly thrilled to see the large deals, and I fully agree that the output needs are massive, but there, I think, is room for all of the players in this sector to benefit from this huge demand.
Yeah, I agree. Generally, the output demand is huge, but individually, how we get there is all different ways, and nuclear is very, very uniquely poised to help us meet those economic goals. Okay, I want to turn to, I'm looking at you first. I want to turn to a Q&A from the audience.
Yeah, so my question is about thorium. What are the plans? What's the thing going on? Because I know thorium is very abundant in U.S. I think we have more than uranium as well. So what's the innovation done in reference to that? And also, if on the side I want to ask, Trump was upset with the Australian reporter a few days ago. Australia has a lot of uranium. Will that be online as well, considering he made some statements against that reporter?
I don't play in that space.
Exactly. I'll answer the thorium one. Most of the reactor technology today that has been licensed around the world is based on uranium. So that's one, right? It's what we know. It's what is so far plentiful enough and so far affordable enough. As soon as that becomes untrue, thorium starts to come into the picture because, as you mentioned, it might be abundant enough. But at this moment, we aren't having that debate. That said, thorium-fueled technologies will still also need to go through that licensing process, so there's that. But there are several different concepts that are exploring thorium, so it's not, I don't mean to diminish or disparage any of the work that's being done there, but that's my opinion of why we aren't seeing more thorium in the market today. And number two, did you say, I didn't hear you.
Uranium from Australia.
Australia, okay. That's what I was hoping you said, because if you said Austria, I couldn't answer the question. So we do get, the industry gets about, I think, 10% of its fuel from Australia and its mining operations. Australia at the moment has a ban on nuclear, which is very ironic because they start they're at the start of the fuel cycle for us, and they are also a member of AUKUS. I was actually invited to speak at a financial review conference out in Sydney a couple years ago, and will never be invited back because I call the government hypocritical for being part of AUKUS and sending their kids out to sea next to a very highly enriched nuclear reactor, but they didn't want to have terrestrial reactors in their backyards. So again, Australia is already part of the mix, but they currently have a ban on commercial nuclear.
And those global partnerships are going to be critical to the U.S. industry taking off. I mean, we've already seen that on the fuel side. David referenced the kind of over-reliance that I think we're all uncomfortable with the Russian nuclear fuel supply chains. You've seen like-minded countries, the U.S., France, the U.K., Japan, and others come together to both commit to waning off Russian fuel products and partnering and finding ways to increase enrichment and fuel fabrication capacity across the globe. That's going to be true on reactors as well. Congress is going to have to act on some critical things like the Development Finance Corporation reauthorization, which actually moved through the House today, the Export-Import Bank of the United States, because we need to build the order book here and meet this increasing demand, but the U.S. has a national security imperative to lead globally, and so we need to be promoting the exciting U.S. technologies that we're developing here to many of our key partners, particularly Eastern Europeans.
And I think you're starting to hear the R word come back around, reprocessing. It helps in two ways. You know, you do build up a little bit more of that domestic supply, but you also can counterbalance some of the challenges that we hear constantly, which is what do you do with the waste? And I always say it's only waste if we waste it, so we need to take advantage of that opportunity while we have it.
I want to check, did we have any come through on the app? Any questions?
We did, but are we good on time?
We have about 4 minutes left. I think we're
Great.
good.
So there is one question on SMRs. What is the pathway for arriving at more standardized design for SMRs? And is there one?
I think it's the licensing process we're going through right now. I mean, our goal and our plan is to license a design that then you repeat. You would have a common training program, which I think is beneficial to, you know, Constellation as an operator. You know, the challenges right now when I worked at Pilgrim is if you're an operator, you're licensed to that one facility, even if it's a sister plant that's exactly the same, you can't get a license on the other reactor. So helping license a design that does not change, that's repeatable, I think will help with both, you know, the potential worries I have about workforce, but also I think make it easier for the industry to grow kind of exponentially.
Go ahead.
I was just going to add, you know, about 90% of the reason you don't have a standard design is it's site-specific stuff. You're not going to have that with Radiant, right? I mean, it's just going to be on the back of the truck or wherever you want to put it.
Yep.
And I think, well, it's exciting. There are a wide variety of companies in the U.S. that are racing to commercialization. There's going to be a natural down selection here over the next 5 to 10 years. There are going to be leaders, and that's not going to be picked by government. It's going to be picked by the customer and by the operators. And so you're going to see certain designs become the go-to option that folks want to develop. And we're kind of at that exciting stage right now where people are racing forward. These early partnerships are coming, and to your point, like now is the prove it time. And as we prove it over the next 3 to 5 years, I think you're going to see a handful of American designs really take off, not only here, but globally.
Okay, so we do have 2 minutes, but I think I would prefer to deliver on schedule, as we would love to in nuclear, and say thank you all for joining me for this conversation. If we can give them a round of applause. Thank you.